All right, we're taking a look at a reaction involving silver. And when we look at silver on a normal basis, if you've ever seen any, what happens over time is that silver will tarnish, and that's because it reacts with sulfur-containing compounds in the air to form silver sulfide. Now, one way to remove the silver sulfide from the silver metal is to react it with aluminum, as you can see in the balanced chemical equation provided here. What we want to determine is what's the theoretical mass of silver that can be recovered if 45 grams of aluminum is completely consumed. So if we use 45 grams of aluminum, we want to determine how much silver we could actually produce. The other thing we're asked for in this question is to determine what the percent yield of the experiment would be if I, Mr. Warner, set up this experiment, was able to recover 324.2 grams of silver. So we're going to work through this problem and see what we can find. I have already written out the balanced chemical equation and some of the given information in the question, and now we're going to work through it. So here we go. So we've got our mass of aluminum provided in the question, as we see, 45 grams. I need the molar mass. So from my periodic table, I'm pulling the molar mass of aluminum. It's 26.98 grams per mole. And having that information is enough that I'll be able to find the moles of aluminum, right? So that's the first thing we want to do. I'll just highlight that with the red, right? So we're going to be able to, the first thing we're going to be able to do is figure out moles of aluminum. From there, we're going to use it to relate to the moles of silver, right? And so the second step is to do our mole ratio. That's going to allow us to find our moles of silver. And then the third thing we're going to do is take our moles and our molar mass and use those two pieces of information to find the mass. That's the third thing we want to tackle here. Now, the molar mass of silver on your periodic table is 107.87 grams per mole. So we've got all the information we need to be able to solve this. So let's work through each piece. So the first piece, we're going to find moles of aluminum. So moles of aluminum equals mass divided by molar mass. So we've got 45 grams divided by 26.98 grams per mole. And that's going to give us 1.66790215 moles. So that's our moles of aluminum. Now that we've got moles of aluminum, the next thing we're going to do is our mole ratio. So this is where we need to make sure that as this reaction happens with the quantity of aluminum that we have, it follows the same 2:6 ratio, right? So we can set it up, number of moles of silver should equal the number of moles of aluminum times, and this is where we put in our conversion factor, which uses the coefficients in the balanced chemical equation. Because I want to find the moles of silver, I'm going to put 6 moles of silver on the balanced chemical equation. That's on top. And on the bottom is my aluminum, 2 moles of aluminum from our balanced chemical equation, right? So the one I want to find is on top. The one I'm getting rid of is on the bottom. And now I can find my moles of silver. We're going to take our 1.66790215 and multiply by 6/2, which really is just multiplying by 3. So when we get our moles, we are going to end up with 5.0037064449 moles. The last thing we want to do then is to do that last step, which is to find mass. So now we've got moles of silver. We're going to find the mass of silver. So mass of silver is going to equal the moles times the molar mass. So this is going to be 5.0037064449 times 107.87. And when we do the math here, we will get 539.7 grams. Okay, and that's to the correct number of significant digits because our mass had 4. Our molar mass had 4. We're carrying 4 significant digits through the first part, which is still the same through the second part. And if we look, we've got 4 significant digits in the moles and 5 in the molar mass. We finish with 4 significant digits. So that's our mass. So we figured out the theoretical yield. Okay. And so let's just move that down. All right, so we'd be able to get 539.7 grams of silver from that reaction. Now it says that we need to figure out the percent yield, given that I was only actually able to recover 324.2 grams. So we're going to take a look at that. So part B, we know our theoretical yield. The other piece of information I'm just going to jot down was my actual yield. This is what I got from experiment, which was 324.2. 324.2 grams. So to find percent yield, remember that it's the actual yield over the theoretical yield. Right? So essentially your experimental amount that you actually get in the lab over what you should get according to your calculations. And then we multiply by 100 to get it as a percentage. So 324.2 divided by 539.7. So we plug that into our calculator, and when we multiply that by 100, we will get 60.07%. So we finish it off with a statement. So his experiment wasn't that great. He got a percent yield of 60%, 60.07%. That's how we do our percent yield. Okay, so just to recap, right, we found the theoretical mass doing some stoichiometry. So we found our moles of aluminum, did our mole ratio to get the moles of silver, and then was able to find the mass of silver. Then in part B, to find that percent yield, we needed the actual yield, which is given in the question. And we used the theoretical yield we determined in part A, and we could find the percent yield.